Okay, this video is over page 21 through 4. So, number one, you have to find the mass percent. So it's just like what percent by mass. And so a percent, remember, is always equal to the part divided by the whole times 100. So they're giving you the whole is the amount of the mixture, the part is the copper. So why don't you pause the video and see if you can do this now, if you didn't understand it before. Okay, so to find the mass percent of just copper, you just take the mass of copper divided by the mass total times 100. So the percent of copper, if you do the math, is equal to 24%. Okay, problem 2. This question is asking whether or not a substance is pure or not. So it's asking if the substance is pure sodium chloride. So the way that you can tell is to find the mass percent of pure sodium chloride. And since they're giving you the percent of sodium that they got, you're going to do the mass percent of sodium in pure sodium chloride. So what you do is you just do the molar mass of sodium chloride, which is, if you look up sodium, it's 22.99, and chlorine is 35.45. And then you do the math here, and so you get 58.44. This was sodium, that was chloride. Okay, so the total mass is that. So to get the mass percent, you take the part of sodium divided by the total molar mass, and multiply that times 100, and you end up getting in pure sodium chloride is 39.34% by mass in pure sodium chloride. Then you do their mixture, that or their substance that they give you, and so they have 3.8 divided by, that's the part, grams of sodium chloride, over 11.5 grams times 100, and you see that that's 33%. Now, in the substance that they have that they're thinking that's pure, that's this one right here, they found that it's 33% by mass sodium, whereas in pure sodium chloride always has a mass percent of 39.34% by mass of sodium. So no, the substance is not pure. Okay, the next question is about how to figure out if a hydrate, the formula for a hydrate. So basically they're taking this calcium sulfate, some hydrate here. Okay, we're looking for that formula there, but they're taking this solid, they're heating it, and it's breaking into calcium sulfate solid, and water would be the gas. Okay, now when they heat it up, they're telling you that they're starting off with 6 grams total of this whole thing here is 6 grams. But after heating it, the anhydrous compound has a mass of 4.77. That's this right there. Now what you can figure out, if you take 6 minus 4.77, that's going to give you the grams of the water, and so that's going to be 1.23 grams water. So then to try to solve this problem, you basically need to find the mole ratio between the calcium sulfate right here, which is 4.77 grams. So you would change it to moles. 1 mole calcium sulfate. The molar mass is 136.14. So you end up having 0.035 moles of calcium sulfate. And then you take this water that you found, 1.23 grams water, change it to moles, and you get 1 mole water, that's 18 grams water. And so the moles of water is 0.068 moles water. Now, this ratio right here will be your mole ratio, but we can't put in decimals like this. So you have to simplify it to a whole number. So to do that, you take the smaller number and divide it by itself, and that equals 1. And then you take the bigger number and you divide it by the smaller number. And in this case, it is about 1.95, which basically rounds to 2. So this is in a ratio of 1 to 2. Now, because we know this side, we can put the 2 in right here for the water. So the formula for the hydrate is there's 2 water molecules in 1 formula unit of calcium sulfate. Okay, so here's how to do the hydrates again. First of all, you're going to have to know the grams of the anhydrous salt, which it tells us that. And then from that data, you can subtract and figure out how much water was lost. Okay, then figure out the moles of the anhydrous salt and the moles of water. Put them in the simplest whole number ratio. You can balance this little equation. Then that tells you what number the water has to be over here. Okay, so now try problem number 4 here on the worksheet. If you can see if you can do that one by itself, but before you watch the video. But then you can watch this video if you get stuck. Okay, so same type of problem. We're taking magnesium carbonate dot blank H2O. We don't know what the formula is. It's a solid. Okay, so we heat it up and it breaks into magnesium carbonate and water. Okay, this would be a solid, this would be a gas. All right, so they're telling us that we have this whole big thing here is 15.67 grams. Okay, but after heating it, the water is driven off, and the mass, then what's left over is 7.58 grams. All right, so if we take 15.67, subtract 7.58, what happens is you can get that that equals 8.09, and that's going to be the mass of your water. So the water is 8.09 grams. Now just change both of these to moles and find the simplest whole number ratio. So magnesium carbonate is 7.58 grams. Magnesium carbonate, you do the molar mass, 1 mole, MgCO3. And let's see, that is 84.31 is the molar mass, I believe. And if you do that math, I believe you get 0.0900 roughly moles of MgCO3. Then you're going to do the same thing. Find the moles of water. 8.09 grams water. And 1 mole water is equal to 18 grams of water. And let's see, if you do that math, you get 0.449 moles water. Okay, now we got to put these in the simplest whole number ratio. So you take the smaller number, divide it by itself, that's going to equal 1. Then take the bigger number and divide it by the smaller number, and that's going to equal 4. This equals about 4.99, which is pretty much equal to 5. Okay, approximately 5. So basically, we have a 1 to 5 mole ratio. Then we just balance our equation to find the formula of the hydrate. We know that there must be a 5 there. All right, that's it for page 20. You didn't have to do number 5 if you didn't catch that when I assigned it. All right, that's it.